Lesson 1. Prime factors. First of all, we need to define what a factor is, and some of you had trouble realizing this on a test. When we talk about factors, we're saying what multiplies together to give you the answer, whether it's a polynomial like last unit or whether it's numbers here. So the whole number 6 is exactly divisible by what goes into 6 evenly? What numbers go into 6 evenly? How about let's go in some kind of an order. I'm going to suggest from smallest to biggest. 1, comma, 2, comma, 3, comma, 4 goes into 6. Oh, and by the way, as a shortcut, you'll notice once you find the first half, you can just start pairing them up. So once we got the 3, and I knew that 3 times 2 was 6, I went back to the 1 and I said 1 times what is 6? I didn't even look at the 4 and the 5. I skipped them over completely to get to that last one. Trick of the trade, right? We would say then that 1, 2, 3, and 6 are the factors of the whole number 6. Therefore, the number 6 has how many factors? 4. State or list the factors of the following. All right, 15. The obvious one. 1. Fancy word for obvious is the trivial one, is what we say in math. 1. What else? 3. What else? 5. And right away I notice, hey, 3 times 5 is 15. I can start pairing them up. I'm going to go back to the 1 and I'm going to say 1 times what is 15? 15. I didn't even bother looking at 6, 7, 8, 9, 10, 11, 12, 13, or 14. Little shortcut for those of you who have not picked up on that one. 24. 1, 2, 3, 4 works. 6. Oh, 4 times 6 is 24. Now I'm going to start pairing them up. I'm going to go backwards and look at the 3. 3 times what is 24? 8. 2 times what? 12. 24. Yes, you're going to need to know your times tables. No, you won't be able to do these on with a calculator because there is a non-calculator section on the provincial exam. 72. Okay. The trivial one, the obvious one. 1, 2, 3. How can you tell? Who remembers the trick from grade 8? Or maybe it's grade 9 when you do divisibility rules. Darian, read the number out loud to me, the big number.
72.
What's 7 plus 2?
9.
Does 3 go into 9 evenly? Then 3 goes into 72. Oh, and by the way, does 9 go into 9 evenly? 9 goes into 72 as well. That trick works for 3 and for 9. So I'm going to remember 3, and later on I'm going to remember 9. 3. Does 4 work? It does. How can I tell? Psst, look up. Put your pencils down. I know my 4 times table. What's 4 times 2? Easy one. I jumped in my head up here to 80. 80 minus what is 72? 8. Are you saying that from 80, which I know 4 goes into because it's 8 times 10, if I go 8 down, which is a couple more 4s, I can get to 72? So 4 must go into it because it's 72 plus 4 plus 4 gets me 80. So you can kind of move around. Or another, depending on how well you know your numbers, I also know that 4 goes into 60. You could have gone 60 plus 12. 4 goes into 12. You can hopscotch your way around a little bit. So I'm trying to give you some tricks of the trade. The other way to check is as follows. If 2 goes into it twice, in other words, if you gave me the number 112, does 4 go into it? What's 112 divided by 2? What's 100 divided by 2? 50. What's 12 divided by 2? So what's 112 divided by 2? And can 2 also go into 56 again? Well, if 2 2s can go into it, what are 2 2s? 4. Another way to figure it out. 5? What's the trick for 5? Ends in 5 or 0. Does anybody know what the trick for 6 is? It's actually surprisingly obvious and easy when you see it. If 2 and 3 go into it. Because what is 6? 2 times 3. If 2 and 3 go into it, then 6 does. Does 2 and 3 go into it? Yeah. 7. Now, you may have been taught that there is no rule for 7. There is a rule for 7, but the reason we don't teach it is the rule is far more complicated and convoluted than simply memorizing the 7 times table. It's not a shortcut. It's like 8 lines. Does 7 go into 72? You know how I know it doesn't? What's a number close to 72 that I know 7 does go into? 70. So 77, because that's 70 plus 7. Or 63, because that's 70 minus 7. But no, 72, no. What about 8? Yeah? What about 9? Yeah, we already said 9, didn't we? Add them up. Okay, and you know what? Why am I happy now that we've got 8 and 9? That's my first pair. Because 8 times 9 is 72. So now I can keep going forward, or I can just start pairing them up if I want to. 6 times what is 72? Psst. Look up. 72. What did I say? 6? Did I say 6? Did I say 6? I see this. I see 72 as 60 plus 12. Is that 72? 60, how many times does 6 go into 60? Come on, Ben. How many times does 6 go into 12? You were right, by the way. It is 12, but I'm trying to give you ways that you can, in a pinch, figure this out if you don't have a calculator handy. I agree. Uh, 4 times what? Okay, you ready? The answer is in front of you. You know where the answer can come from, Brianna? That guy. 8 times what? What did we say? 8 times what? Times 9. Is 4 half of 8? If 4 is half as big, 9 better get twice as big. 18. It is. Three. Oh, hey. The answer is right in front of us. 6 times what? What was it? 6 times what? 12. If 3 is half as big as 6, then the 12 better get twice as big to compensate. 24. Have you guys never been showed these tricks before? If you haven't, keep your eyes open. 2 and what? 36. Did you get that? Or you know what? Most of us are pretty good at doubling in our 2 times table. Pretty good. Or did you go half of 4 and double the 18? Because if you did that, I'm impressed. Half of 72. Totally works. Oh, and hey, let's get the, hey, at least it gets easier at the very, very end. 1 times what? 72. Okay. Example 2, these are smaller numbers. It says determine the number of factors of the given whole. So they don't want you to list the factors. They just want you to say, how many? So 20. How many? You know what? The easiest way to figure out how many is to list them. So what are the factors of 20? 1, 2, 4, 5. Oh, there's our pair. So 4 and 5 go together. 2 goes with 10. 1 goes with 20. How many factors grand total? 6. Can we do B in our heads, please? Yep. Woohoo! You know what? I even think we can do 7 in our heads. How many factors does 7 have?
2.
I've heard 0, 1, and 2. Which one?
2.
What are they?
7.
The fact that it has two factors, we're going to classify those with a special name. 18. Well, it's got a 1, a 2, a 3, 4, no, 5, no, 6. Oh, 3 and 6 go together, so 2 and 9 go together, 1 and 18. How many factors? Also 6. Okay. What do we call the number 7? What do we call any number that only has two factors, itself and 1? And if you're not sure, look down one line.
Prime number.
Prime. They're sort of like the periodic table of the elements to chemistry. All of the elements are made up, all of the compounds, everything in the universe is made up of those 130 some elements on the periodic table. All numbers are made up, prime numbers are like the building blocks of all other numbers. So a prime number is when a factor of numbers, when a number, how about let's go like this, when a number has exactly two divisors or factors, one in itself. As an example, 3 is 1 times 3. It's prime. 64 is not. In fact, 64 is 2 times 2 times 2 times 2 times 2 times 2, I think. Is that right?
Yeah.
2, 4, 8, 16, 32, 64. Okay. What's the opposite of a prime number? A composite number. A composite is a whole number which has more than two factors. Example, 10. 10 has 1, 2, 5, and 10. It has 4 factors. Or 48, which has lots. Well, let's list them just because, it's kind of fun. 1, 2. Does 3 go into 48? Add 4 plus 8 up, and if 3 goes into that. By the way, if you're really lousy with your times tables and you add 4 plus 8 up, you get 12. You can add 12, 1 plus 2, and get 3. Yeah, see, 3 works. Does 4 work? Mm-hmm. You know how you know? Does 4 go into 4? Does 4 go into 8? Then it'll go into the whole thing. Does 5 work? Does 6 work? 2 and 3 do. 6 must. Does 8 work? 6 times 8 is 48. That's how I memorized that one when I was, good gosh, in grade 3 or grade 4, and I still remember it that way. In fact, if you ever give me 8 times 6 and you see my eyes go glazed, I'm not going 8 times 6. I'm reversing it, and I'm going 6 times 8 is 48. And you'll notice, Amber, now we have a pair. So 6 goes with 8. 4 times what? Oh, because it's going to be twice as big as what 8 needs. Yeah, 12. 8 needs a 6, so 4 needs a 12. 3 times what? Ooh, nice catch. 2 times 24, because it's going to be twice as big as what the 4 needed. And 1 times 48. 48 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factors. Jessica, the weird number, Sesame Street is brought to you today by the number 1. The number 1 has only one factor, and so it's neither prime nor composite. It's special. My mom says I'm special. Not that way, Brody. It's special because it just doesn't fit in. Well, that's the way my mom says I'm special. Okay, fair enough. Maybe you don't. Okay. You should know the primes. I'm going to say this. You really should have the first 20 or so primes memorized. But what I mean by memorized, Darian, is you should recognize them when you see them. I'm not necessarily going to say to you, hey, spit out the first 20 primes. What I am going to say is, if I give you the number 19, prime or not, that's what you need to know. 19, prime or not?
Prime.
It is. Let's list out the first few. 2, 3, 5. 7. 9?
No.
No. Just because it's odd. What goes into 9? 3. So don't write 9. What's the next one then? 11? 13? 15? No. 17? 19? 21?
No.
23? 25? In fact, you know what? I'm not going to say anything that ends in a 5 anymore. I'm going to skip that, right? And I'm not going to say any even number anymore. So 26, no. 27? 27?
No.
Oh, no, because that 2 plus 7 is 9, 3. Okay. 28, no. 29? 31? What about 33?
No.
Nope. 35, I said I'm not going to. 37? 39. A lot of people want to say so, but wait a minute. 39 is a 3 and a 9. If you add those up, 3 and 9, 3 goes into that, so no. 41. How many are we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, lots more to go. 43. Skip 45. 47. Think so. 49.
No.
No, that's in fact that's 7 squared. The one most kids get wrong is 51. Yeah. 26, is that an even number? So 2 goes into it, right? Any even number aside from 2, 2 is the only even prime. After that, every even number, 2 goes into it. So as a shortcut, you can skip all the even numbers besides 2. 51? Well, you know, what's 5 plus 1? Does 3 go into 6? Then 3 goes into 51. It's 17 times 3 for those of you who know your 17 times table. 53. How much further are we going? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. 4 more. 55, no. 57? Oh, 5 plus 7 is 12, and 12 goes into 3, so no. 59. $61. Think so. 63. No, that's part of the 9 times table. I got that one memorized. 65. Oh, it ends in a 5. 67. 69, nope, add those together, divides by 3. 71, I think so. I'm always worried because I don't know my 13 times table very well and my 17 times table, and every once in a while I get bitten by one of those. So, example 3 says, classify the following whole numbers as either prime or composite. How about let's use P for prime, C for composite. 46, Simi, is 46 an even number? Then it's composite. 2 times 23, at least that works. Maybe more. 37, prime. 101. Who says composite? Convince me. Now, this is where, okay, I know 2 doesn't work. I know 3 doesn't work. If 2 doesn't work, 4 won't work. In fact, no even number will work. I'm going to skip that. Try 101 divided by 11. No. 11 is 99, or so 11 wouldn't work. I would try 13, 17, and 19 on your calculator. See if any of those work. (101 divided by 13). You'll notice I'm only trying other prime numbers to see if they go into here. 13? What about 101 divided by 17?
No.
What about 101 divided by 19? 23 doesn't work. $29, 101 divided by 29?
No.
Okay. I think it's prime. What about 103? Oh, how? What? What goes into it? 3 does? I get 1 plus 3 is 4. 3 does not go into 103. Is that an even number or an odd number? So if 2 won't go into it, there's no way 4 can go into it. Let's see. And I'm going to try weird ones. I would go 103 divided by 13. Nope. Divided by 17. 19. 103 divided by 23. I'm trying all the big primes. 103 divided by... Sorry? 37? Didn't work. 103 divided by 31. 103 divided by... 39 is not prime. If 3 doesn't go into it, neither will 39. Did I try 29? I can't remember. I think it's prime. 57? Now, I don't even need to try that. You know why? What's 57 times 2? 57 times 2 would be 114, so 57 won't go into there. I think we're prime. Now, having said that, Jordan, we're not going to be giving you too many of these size numbers, but these ones are absolutely fair game. Stuff below 100, yeah. So, prime factorization. The prime factors of a whole number are the factors of the number which are prime. So, for example, the prime factors, the factors of 6 are 1, 2, 3, and 6. The prime factors of 6 are 2 and 3. No, 1's not prime, because 1 doesn't have 2 divisors. It doesn't count, right? It's special, like Brody. So, example 4 says, state the factors of 12. 1, 2, 3, 4, 6, and 12. Which of those are prime? And then C says, express 12 as a product of prime factors. What we're really saying is, using only these numbers here, write something times something times something times something times as many times as you need. That works out to 12. Let me see it. What? I'm going to go from smallest to biggest. 2 times 2 times 3, except I'm going to get really lazy. There's a shorter way to write 2 times 2. I'm going to actually write it as 2 squared times 3. We call this the prime factorization of a number. So, next page. Every single composite number, non-prime number, can be expressed as the product of primes. So the prime factorization of a natural number is the number written as the product of its prime factors. Say what? Example. Write the prime factorization of 48. Now, there is a way to get there systematically, and I'm going to show you 2 methods for getting there systematically. Many of you will kind of reach the point where you'll just kind of see the answer, and that's great too. But if I want to write the prime factorization of 48, I start out with a little division table, and I pick the first prime number that I can find that goes into 48. What goes into 48 and is prime? 2. What's 48 divided by 2? What's a prime number that goes into 24?
2.
And what is 24 divided by 2?
12.
What's a prime number that goes into 12?
2.
And what's 12 divided by 2?
6.
And what's a prime number that goes into 6?
2.
And what's 6 divided by 2?
3.
And what's a prime number that goes into 3?
3.
And what are we left with?
1.
Here is your prime factorization. How many 2's do you need grand total? Count them. 4. How many 3's do you need?
1.
48 is 2 to the 4th times 3 to the 1. Am I going to bother writing the to the 1? No. I like that method because I can do most of that almost in my head. Second method is what's called a factor tree. And the factor tree method says, pick any numbers that go into 48. And some of you may like this if you're a little shakier on your times tables. If you know certain times tables better than other times tables, you might have some fallback. So some of you, when you see 48, you might say, hey, that's a 6 and an 8. Then you say to yourself, what does 6 break into? 6 is what times what? 2 times 3. And when you're using the factor tree method, as soon as you write down a prime number, you circle it. What does 8 break down into?
4 and
2,
2.
4. Oop, 2 is a prime number. I'll circle it. Would I circle 4? No. What does 4 break down into?
2 and 2.
Hey, that's prime. That's prime. Can you see I also got an answer of 4 2's and a 3? See the circled stuff, Simi? This also gets you there. Okay. With which method's correct, Mr. Dewick? Yeah, they both are. They're both fine. So, example 5. This method works great for really big numbers, like 3,300 or 2,772. It says, write the prime factorization for each of the following. Use the factor tree or division method. You know what? Let's use the division method for A, and let's use a factor tree for B. So let's draw a little line down the middle right here. And I'm going to write down 3,300. And I'm going to pick a prime number that I know goes into 3,300. 2 does? And when you go 3,300 divided by 2, what do you get? If you need your calculator, use it. Although some of you said, well, I can divide by 2 in my head. 1, 5, and 150. 1650. Double check my math. 1,650?
Yep.
I'm right? Cool. What's the prime number that goes into 1,650? I'm going to do 2 first, and then I'll come back to 5. Because 2, I can do with really big numbers and feel fairly confident that I'm not going to, I'll spot a mistake. So let's divide by 2 again. 16 divided by 2 is 8. 825? Yeah? What's the prime number that goes into 825? 5. All right, what's 825 divided by 5? Let's see if I can do this one in my head. It's going to be 175 is, oh gosh, Mr. Dewick, 20 and 75 more is 15. So 200 take away 20 is 180, take away 50. 165?
Yeah.
Woohoo! I can do math in my head. Oh, 5 goes into 165?
Yep.
Oh, let's keep going just for the heck of it. 37? 33. Yes, 33 Terrible. What? 3?
Yep.
Ah, sure. 33 divided by 3. What prime number goes into 11? 11. We're down to 1. So, this is going to be, how many 2's? 2 squared times, how many 3's? 1 times, how many 5's? Times, how many 11's? 1. Ta-da! B. So let's do a factor tree. Boom, boom. What goes into 2,772? Well, I know 2 does. So let's try that first. And since 2 is prime, I'll circle it to say, that's part of my answer. What is 2,772 divided by 2? 1386? Now this branch right here is done. Because 2 doesn't break down any further. Hey, what goes into here? 1386.
2.
Let's go 2 this way and what?
683.
603? I wrote the 2 on the right because I knew I'd need more room.
No, 693.
693, that's what I wrote. Let me make that 9 a little clearer so you can see. Oh, that didn't work. Nice try, Mr. Duke. 693. You could have put the 2 here and the 693 there. I just said, you know what? The 2's a dead end and I need to move to the middle so I have more room. That's not math. That's just me thinking through, right? 693. Oh, 3 goes into 6 and 9 and 3. It's going to go into all of them. So 3, yoink. And 2, 3, 1. Three works again?
Yeah. Yep.
Yeah, it does?
77.
3, yoink. 77, and I can break this down, except I'm running out of room. 77, that I can do into 2 prime numbers in my head. 77 is what times what?
11.
7 and 11. Okay, running out of room. Oh, I love being able to cheat like this. You guys can't, but I sure can. Oh, that didn't work. Come on, Mr. Duke. Yoink. Make a little smaller. Ha ha. 7, 11. Okay. So, final answer. How many 2's?
2.
How many 3's?
2.
How many, no 5's? How many 7's? 1. How many 11's? There's the prime factorization of 2,772. Is that okay? Greatest common factor, GCF. Last unit, we kind of did GCF in our heads. There is a method to get there. The greatest common factor is a set of, here's the definition. It's the set of whole numbers, which is the greatest common factor the numbers have in common, that divides evenly into each of the numbers. For example, what's the biggest number that goes into all 3 of those? Because that's really what that paragraph is saying in math speak. 4. What if you're given really big, yucky stuff and you need a system to find, well, you can start out by doing some of these in your head. What's the GCF of 15, 25, and 35? 5. What's the GCF, the greatest common factor of 18 and 20?
4.
Which one, 4 or 2? 4 is what I started out as my guess. I checked, does 4 go into 18? Nope. So I whittle it down. Instead of a 4, I'll try a 2. And 2 works. What about 36 and 48?
12.
I tried 6 now. If I'm doing it in my head, Garrett, as soon as I try 6, I'll automatically double it and try 12 just to be safe. And sure enough, 12 does work. What about 24? Nope. And Alex, I believe the in-your-head method for numbers that are reasonably small, it's the quickest, most efficient method to get there, if you know your times tables. But we need a method if the numbers are big. So, to find the greatest common factor, we write the prime factorization of each number using a factor tree or a division table. And then we find the product of each common prime factor, each prime factor that appears in both numbers, or all numbers if there's more than two. It's easier to explain, it's easier to do than to explain. Turn the page. Did I leave you a bunch of room to find the GCF between 138 and 198? Get your calculators out, all of you. Here's Mr. Dewick's combination of a division table, a factor tree, and your calculator in one line showing minimal work. Continue. This is how I do this on my calculator with a minimal amount of work. You've heard me say maximum bang for my buck, minimal amount of work. Start with 138, and I would pick a prime number that I know goes into 138. What's a prime number that I know goes into 138? I would go and I would write down 2 times. What's the number that goes into this? What I have here, what's the number that goes into that? And I would say times. What's the number that goes into 23? Ah! It's prime? Then I'm done. I got a 69 right there, divide by 3. By the way, if 6 and 9, if 3 goes into each of the digits, it'll go into all of them. That's the quickest way to get the prime factorization. Brianna, it only works if you have a calculator handy, and I have to show you a method for the non-calculator section of the provincial, hence the factor tree division method. Ready? 198? What would I try first for 198? 4 is not prime. I'm going to try 2. I want primes. And by the way, what's a prime number that goes into 99? Don't say 9, because 9's not prime. What's a prime number that goes into that?
3.
Now, some of you may have said 11, because that's the first thing you spotted. Fine, you don't have to go smallest to biggest. It's convenient, but let's go 11. Oh, let's write it down. See, now that I have the number 9 displaying, I think I can do the prime factorization of that in my head. 9 is, what is the prime factorization of 9? How many 3's? It's 3 squared. Okay. Now, to get the greatest common factor, what you want to do is visualize these 2 rows of numbers right on top of each other. In fact, over here in the margin, I'm going to go 2 times 3 times 23, and underneath it I'm going to go 2 times 3 times 3. I'm going to spread it out times 11. You know what the GCF is? Start pairing up ones that appear in both. One of those. I got 2 3's in the bottom. Do I have a second 3 in the top? No. I got a 23 here. Do I have a 23 here? I got an 11 here. Do I have an 11 up there? You know what the GCF is? Six. Let's see if we're right. 138 divided by 6 works. 198 divided by 6 works. 2 and 3 are the pair. See it? And I'm going to write here. It's 2 times 3 times nothing, 2 and 3. Sam, that's not the best way to find the GCF. The best way to find the GCF is just to see it in your head. Example 7 says, find the greatest common factor. I'm thinking maybe 5, but I'm not quite sure because I know 5 goes into 90 and I know 5 goes into 225. Maybe not. So here's what I'm going to do. I'm going to write 90 equals. Underneath it, I'm going to write 225 equals. And let's see if we can cheat and use our calculator and be clever. 90, what's a prime number that goes into 90? Start smallest to biggest if you can. It helps. 2. What's a prime number that goes into 45? 3. Yes, 5. We'll get there. Patience. Oh, wrong one. 15, I can do the prime factorization of that because I know 2 prime numbers that multiply to 15. Another 3, another 5, and a 5. 225. What's a prime number that goes into 225? 5. 5 again. I got a 9. 9 is what times what in terms of prime factorization? 3 times 3. Now start pairing up numbers. Let's see. I can pair up that 3, and this is why it's nicer to go in order so you don't end up crisscrossing the way that I did. 5 was fine, Kira, but I would have tried to find the 3 first. Anyways, a 3, and a 5. The GCF is going to be 3 times 5. Turns out the greatest common factor is 45. I thought it was 5. I was wrong. Actually, I thought it was 15, and I was wrong. It was a bigger one. By the way, this also works if you have 3 numbers, except instead of pairing things up, you triple things up. They have to appear in all 3. Or if you have 4 numbers and you want to find the GCF, they got to appear in all 4. 154 and 198. You know what? Try this one on your own. Those of you that don't have a calculator, try and look in on somebody else's stuff. I'll do it up here. Let's see if we end up in the same place. And you may find when you get to smaller numbers that you don't need to use your calculator anymore. For example, I reached a 33 at one point, and I said, oh, for Pete's sake, that's 3 times 11. I got 10 minutes left. How far am I going to get? I am not getting through the rest of the whole lesson, am I? Okay. That's all right. How many got 22? Okay. Okay. It gets you there. The best way still, Anthony, is just to know your timetables so well that you can see the answer. And for most stuff under 100, I can do that. Yeah, where we're in the hundreds or the thousands, I don't even try. That's a lie. I do try and see if I'm right, and then I do it the long way and see if I got it right, because I'm, anyways, math nerd. Least common multiple. So greatest common factor asks, what's the biggest number that goes into everything? Least common multiple asks, what's the smallest number that everything goes into evenly? For example, multiples of 6 are 6 times 1, 6 times 2, 12, 6 times 3, 18, 6 times 4, 24, 6 times 5, 30, etc., etc., etc. Multiples of 8 are, well, what's 8 times 1? Then 16, then 24, 32, 40, etc., etc. Oh, let's keep going. Let's add 48. And to the 6th list, let's add 36, 42, and 48. What are some common multiples of 6 and 8? Which numbers appear in both lists? 24, 48. What's the least common multiple? What does the word least mean in English? Smallest, lowest, 24. Best way to find the least common multiple is to kind of do it in your head intuitively. It's the fastest way. But I'm going to give you a method that'll get you there if the numbers are really big. Pause for 1 second. Hang on.